So let's talk about nonpolar covalent bonds. So we know the covalent bond is a sharing of electrons, but in some instances, that sharing can be equal, and we call that nonpolar. All right. So in diatomic molecules like I2, iodine, H2, hydrogen, nitrogen, bromine, oxygen, chlorine, fluorine. And the easy way to remember this is this anagram here. I have no bright or clever friends. So the first letter is that element, and sometimes the first two, like in bright or clever. The electronegativities. So remember, electronegativity is how much atoms want those electrons. And if they're the same electron, or if they're the same atom, it would stand to reason they want the electron the same amount. Okay, so if they're the same atom, they're gonna want they're gonna pull on the electron with the same force. So those electrons are shared equally, and these are nonpolar covalent bonds. And here we got a little tug of war with hydrogen, and it wants the electron the same amount. So we're gonna call these nonpolar covalent bonds. So there's equally shared. What about if you have atoms of different electronegativities, different atoms? Are they going to share it unequally? And the answer is yes. They're called polar covalent bonds. When atoms, electrons are shared unequally between atoms, the bond is called polar. So an example here is water. Hydrogen has a low electronegativity. You see hydrogen and oxygen. So when it bonds to oxygen, the shared electrons spend most of their time in orbit around oxygen. So oxygen has a higher electronegativity. It's going to pull those electrons toward it. And these little signs here, okay, these little symbols are the Greek letter delta. It means partial. So there's partial negatives around oxygen because it's pulling those electrons toward it. And there's partial positives around hydrogens because those electrons are kind of receding from, they're moving away from the hydrogen. All right, another important term is a dipole. A dipole is a partial separation of charge resulting in a polar covalent bond. A dipole exists when one end of a molecule has a slight positive charge and the other end has a slight negative charge. So water here has two dipoles. Okay, there's a slight positive at this hydrogen, a slight negative at the oxygen, and a slight positive at this oxygen, and a slight negative at the oxygen again. So two dipoles. So which atom in the water molecule has a stronger attraction for electrons? Sorry, you saw my food right there. That's going to be oxygen because it has a higher electronegativity. Okay, and then which one? Or the other question is, if the shared electrons spend more time around an atom and a molecule, what will the charge be around that area? For example, if the electrons spend more time, excuse me, I know that's loud. If the atoms spend more time, not atoms, the electrons spend more time hanging out around oxygen, what do you think that charge is going to be? And remember that electrons are negative, so if there's more negatives around a certain atom, the atom is going to be negative. Okay? Oxygen is going to pull electrons toward it, and it's going to be have a partial negative charge. Okay, some properties of covalent compounds. They exist as gases, liquids, and solids. They're usually bad conductors of electricity, and they're not very soluble in water. So some things I want to highlight here is that they're not very soluble in water. Okay, low melting point, low boiling point. So we're seeing a lot of opposites when compared to ionic bonds. And what else? What else? I don't want to say bad conductors of electricity because remember actually that video of salts conducting electricity when it's aqueous or dissolved in water. Okay, so these are the last slides I'll be going over. For the next two slides, you watch these two videos, you will get these answers here. And let's go over 14 just quickly. I'll go over a few of them with you. So what you're going to do is you're going to identify the elements in each formula, categorize them as metals or nonmetals, and then determine the type of bond for each compound. So let me bring in our friend P table. Okay. So here's P table. And let me just add this link really quickly. Boom. And I don't know, it always shows up as this really lavender color. I don't have anything against it, but it's just really hard to see. Let me make it a little bigger. And can I make it way bigger? Yeah, really big so you can see it. And let's make this color nice purple. Can I do purple? No, that probably won't look nice. How about just yellow? There we go. All right, so link to P table. Let's click on that. Takes you to P table. All right, so first two are done for you. What about CH4? So where's carbon? All right, carbon's here. Let me move myself down here. Actually, move myself over here. So here's carbon. If I mouse over nonmetals, it says carbon is a nonmetal. All right. And also, hydrogen is a nonmetal. The two atoms in our formula is carbon and hydrogen. And are any of those metals? No. So put none. And then nonmetals, well, they're both nonmetals, right? Let's go to nonmetals. We see carbon here. We see oxygen or hydrogen here. Again, I'm just mousing over and it's showing me which ones are the nonmetals. Okay? I see the C for carbon and the H for hydrogen. Nonmetals, carbon, hydrogen. So what type of bond is it? If they're both nonmetals, it's going to be covalent. All right, do one more for you. Aluminum and oxygen, Al and O. All right, so where's aluminum? Oh, it's right here. It's the one I said that wasn't a transition metal. It's not really a transition metal. I might have said it wasn't a metal. And that was wrong. I don't know if I said that or not, but if I did say it, I was wrong. And I apologize. So mouse over metals, this little box at the top. Aluminum is lit up, so it's a metal. So I'll go back to metals, but aluminum and nonmetals is oxygen a metal? Do we know? Let's find out. Nonmetals. Oxygen's lit up if I put my mouse over nonmetals. So oxygen is a nonmetal. So I'm done with the metals. Go to nonmetals. Oxygen. And then type of bond. I got a metal and a nonmetal. It's ionic. All right. So the recap, nonpolar covalent bonds, electrons are shared equally. Polar covalent bonds, electrons are shared unequally. We got some properties. They're pretty much the opposites of ionic bonds. Bad conductors of electricity. They're not very soluble in water. And they have low melting points and low boiling points. And you can see they're made up of nonmetals.